This video is about using Avogadro's number to go back and forth between grams and moles and particles. So we're going to convert between mass and moles and representative particles. And remember that representative particles can be atoms or molecules or formula units, depending on what you're talking about. So sulfur trioxide, which is SO3, which is made in a factory with sulfur and oxygen. How many moles do we have of SO3 if we have 200 grams of sulfur trioxide? So we're going to first convert between grams, which we're given, which we measure in the lab. We have to always convert first to moles. So write out the formula, calculate the molar mass, and just like we just learned, go from grams, divide by molar mass, grams per mole, and convert to moles. Next step, we're going to calculate the number of molecules. We call them molecules because SO3 is covalent, so we call them the groups, we call them molecules. So again, we started with 200 grams, so we already converted to moles, so now we're going to go from moles to molecules using Avogadro's number. So we have the number of moles, 2.50 moles, and multiply by the number of molecules in 1 mole. Moles has to cancel, so Avogadro's number is going to be on the top, and that's going to let us calculate the number of molecules. It's a very, very big number. These numbers are always going to be huge. So how many sulfur atoms? And how many oxygen atoms? So here we look at the formula. SO3 has 1 sulfur for every molecule. So the number of sulfur atoms is going to be exactly the same as the number of molecules. There's 3 oxygens for every molecule, so the number of oxygens is going to be the number of molecules times 3. Okay, 1 sulfur per SO3, 1.50 times 10 to the 24th, sulfur atoms, exactly the same as the number of molecules. 3 oxygens per SO3, so we're going to take that number and multiply by 3, get 4.5 times 10 to the 24th oxygen atoms. This is all in 200 grams, so everything that we did was talking about 200 grams of SO3. And remember that grams, you have to start with grams because that's what you can measure in the laboratory. So to practice, do the next 3 problems. The first thing that you're going to need to do is figure out the formula if you're not given the formula, calculate its molar mass, and then starting with grams, go to moles, and then calculate molecules or atoms. Shut off your video, work through these yourself, and then turn it back on. So the plan is molecules, convert to moles, and then convert to grams. This one goes backwards, and I did these a little bit out of order, so just bear with me in the video. So this is the opposite of what we did with SO3. We started with molecules. We divided by molecules per mole, Avogadro's number. That gave us the number of moles, and then we went from moles to grams. So these are strung together in one series of conversions. So moles cancels, and that will give us the number of grams. Okay, number 4 is a different kind of question. You are given 1 gram samples of helium, iron, and lithium. Remember that molar mass is the number of grams per mole, and that means the exact same number of particles. So for helium, for 1 mole, you're going to have 4 grams. Iron, you're going to have 58 grams. And lithium, you're going to have 6 grams. So which one is going to give you, for the same mass, which one is going to give you the most particles it's going to be the one that is the lightest, that has the lightest molar mass. Kind of like if you had a pound of feathers and a pound of rocks. A pound of feathers is going to be a lot more feathers than a pound of rocks because the feathers are really light. So in this case, helium is the lightest. So if I have a gram of helium, I'm going to have the most atoms or the most particles. Highest number of atoms because it is the lightest. Iron is going to have the smallest number of atoms because iron is the heaviest. Iron has 58.85 grams per mole, so it's much, much heavier. And lithium is going to be in the middle. Back to number 2. The plan for number 2, this is exactly what we did on the previous page with SO3. We're going to go from grams to moles using Avogadro's number, moles to molecules using grams to moles using molar mass, moles to molecules using Avogadro's number, and then we're going to use the formula to figure out how many atoms there are in each molecule. And this is going to be for aspirin, which has the formula C9H8O4. So walking through this step by step, starting out with grams, we're going to go from grams to moles. 180 is the molar mass of aspirin. And then we're going to go from moles to molecules, and that's using Avogadro's number. Moles cancels. And then for every molecule, I have 9 oxygen atoms. So we're going to use the formula for that, multiply by 9, and that gives us the number of oxygen atoms. We also could have written out the calculations for, grams to moles and calculated the number of moles. That could have been the question. How many molecules? And in this case, we have how many oxygen atoms, and I strung them all together in one equation. But we could have asked any number of questions about this scenario.